All right, here we go. Here's the new section. Last week we did adding and subtracting, multiplying and dividing of equalities. Now today we do inequalities.
And that doesn't mean like inside equalities. It means the opposite, as in invertebrates don't have vertebras. They don't. No. Okay, here we go. I'm going to click this. And since this is, what is this, the third lesson since the test? I'm going to go ahead and do to the left of my, is this still there? To the left of my red line, I'm going to do a 3. We're going to start doing a different layout. Okay, so that would be add, subtract, multiply, and divide inequalities. If you don't have that there, it's a Roman numeral 3 to the left of your line. So you would have this written right here. How big is that? View 75. Too small. Okay. Now, last week we learned the properties of equality for multiplication, division, subtraction. The properties of inequality are the exact same. So this is going to be one finger width. So don't write this, but if you were to put your finger down, here's your nail. Okay? Okay? You put your finger down, you put A just inside of that. So it's one finger width away from the red line. A. Addition, too thin. Subtraction. Multiplication. And division properties. Are exactly, I'm not going to say exactly, that's permanency, are, oh, so similar. Yep. To the properties. And the properties I'm referring to are the ones we did last week. To the inequality. We're doing inequalities today. So I'm referring to the properties that we learned of equalities. That's why I'm saying the property, here. There, of equality. So that means that yes, question? Properties. And notice how I'm not going any closer to that sideline other than where my first letter was, my first word was. That helps you organize your notes and see what's a subcontext, what's further. Context that's even smaller. This isn't LA. We're just going to continue going with it. Okay. What that means is, I'm going to go lowercase Roman numeral. What that means is, it's an I, a lowercase I, dot, close parenthesis. Last week we learned that multiplying the same thing on both sides of the equation is going to be same equal. If I have A is greater than B, then that means that A plus C is still, I'm going to circle this, greater than B plus C. See how similar that is to what we did before? That's ugly. I'm going to rewrite that. It's not clean. There. So it's similar to it. If it's less than, A is less than B, then A divided by C is also still less than B divided by C. Do I need to go through all four of these? Okay, I'm kind of inferring here a little bit that you'll see that connection. I'm just saying the inequality properties are so similar to the equality properties, just with the word inequality. Yeah?
Would you mind if I just brought a different math book every other day?
Yes, unless you purchased them from Amazon for a couple of dollars.
Mom's friend, daughter's year older than me, so she gave me a set of books.
A set of those books. Those exact books, that publication. Oh, I don't care. As long as when the end of school year gets here, you hand me that book and it looks just as good as that, I don't care. So let's get some with examples. So let's do m plus 4 is less than 9. M plus 4 is less than 9. And we are trying to solve for this inequality. We are solving for the variable. I'm going to write examples here. Examples, here's example 1. Examples, m plus 4 is less than 9. So what's happening to our variable? What's happening to our variable here? Raise your hand. Yes? It's getting increased by 4 in order for it to be true to be less than 9. So in order to undo that, we have to add 4, subtract 4 from both sides. Now we have m is less than 9 minus 4. Everybody? 5. Good. Just making sure we're keeping with our integers. And I circle that guy. Two. Ew. Ooh, I gotta graph it. Gotta graph it. Now I want you to create a graph to the right of it by doing this. Get a line and have about 2, 3, 4. 1, 2, 3, 4. Now there are multiple ways of doing graphs. I think the most obvious way to do it is you will put your variable, or what it's supposed to be, right in the middle. Yes, sir? Nope, we keep the inequality. We're going to get to something else. But let me graph it and I'll demonstrate how that goes. So I'm going to use a different color here. I'll go with blue. I'm going to put my 5 in the middle. And I'm going to put an open circle. You put an open circle in there, that is very important. You put an open circle in the middle because you need to show that it's not including that number. It's just everything less than it. So I have a circle over 5, and then I have to include everything to the left. I'll explain. Everything to the left. So it's an open circle. We wrote a 5 in, and I'm also going to do 6, 7, 8, 4, 3, 2, 1. And that arrow at the end of it shows everything that way on the number line. So I'm going to test it out. See how 4 here has the line going through it that we just made? Yes? Oh, and also if you're looking for a school-issued straight edge, you have it with you all the time.
I don't.
Okay, you should. You're supposed to. You're supposed to have your ID on every day, all the time now. So let's test it out. Is 4 less than 5? Ding, 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 ding. Is negative 278.314 less than 5? Yeah. So I'm checking myself so there's no wreckage, okay? Since that goes everywhere left on that number line, we know that it's true. Let's do number 2. Go back to the black color, because it pops. 2. We're going to do negative 13 is greater than or equal to x minus 8. Negative 13 is greater than or equal to x minus 8. That kind of looks like a nose. Now I have to undo what's being done to it. And it is going 13, or 8 is being taken away from x. Somebody's taking 8 away from x. So to make them feel better, we're going to give them 8. Because x wants to be alone. Okay? So we're going to give them 8 so x can be alone. And I need to add it also on this side as well. Because of the inequality, the addition property of inequality, if you do one thing to one side, you can do the exact same thing to the other side. Write my sign again. Now x is by itself over here, and we have negative 13 plus 8, which is going to give me negative 5. Circle that guy, and it's time to graph. What number am I going to put in the middle? Negative 5, thank you. Negative 5, negative 4, negative 3, negative 6, negative 7. Yes, sir? Can you use your glasses? I'm going to take this 5 and I'm going to have a circle. But here's the thing. It's less than or equal to. So that means that I am going to be filling this in now. It is a closed circle. Closed circle. Closed circle. Then it has negative 5 is greater than or equal to x. Which way should my arrow go? I need to find the greater than or equal to. What do you think, Bert? To the left? Let's see if that's correct. Oh. Sadness. Okay, good. Okay, to the left, to the left. All right. To the left. Let's test it out. Let's pick a 7, okay? Test. Negative 5 is greater than or equal to negative 7. Is that true? Yeah. Yes, that is correct. So, this example shows that less than, greater than or equal to, or less than or equal to, filled in circle. Filled in circle. Yes?
So if you just do that second line where the sign
What? The second. You mean my thick blue line? It's whatever helps it to be true.
I know it goes out which way
Exactly. If this here would have been like that, then the line would have gone to the right. Correct. Because it has to be everything. And that's how we're doing. That's why we did that test. If it wouldn't have been, like for example, if we did negative 4 here, is negative 5 greater than or equal to negative 4? No. So you mean that would mean that you did your sign wrong. Okay, let's do number 3. Without my watch on that hand. Draw. It's too thick. 3. Yeah, we got a whopping 4 examples today. Yeah. How about 4x is less than negative 28? What's happening to our x? Okay, it's being multiplied by 4, so we have to do the inverse operation, which is divide by 4. And I need to divide this side by 4 as well because of the division property of inequality. So I'm left with my 4 all alone over here, less than negative 7. That's why if you had the negative wrong on last night's homework for the 2 of you that asked me, that's why it's wrong, because this here, it's huge whether you remember the idea of a division or multiplication. If you have an odd number of integers that are negative, the final result is going to be negative. All right, let's graph these after I circle this. Oops. In the middle, I'm putting my negative 7. Negative 7. Which means it's going to be negative 6, negative 5, negative 4, negative 8, negative 9, negative 10. Is my circle going to be filled in or just a circle? Is it going to be a circle or an outline? What is it going to be? Just a circle or circle outline? Circle outline, okay. Just want to make sure. Oops. Whoa. It's a circle outline. Circle outline. And then I'm going to go to the left. 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 I like really thick arrows, and I cannot lie, so you can see exactly what you're doing. Yeah?
How do you know exactly where it is?
When I say x is less than negative 7, less is left on the number line. I'm actually going to give you a little trick as far as that goes at the very end. Okay? It's less. That's why we test. We're going to test it right now. You know what? Imagine you didn't. Good question. Imagine you haven't drawn that thick part of the line yet. So let's test something. Give me a number that you can see on my map here. Okay, negative 8. Is negative 8 less than negative 7? And negative 8 is right here, which means that you need to go that way. Because it's true. True. Or if you went the other direction, if you want to test for x being 5, let's say, 5 is less than negative 7. That's not true. So that means that the arrow does not go that way. Does the testing make sense? Do you agree that negative 5 is not less than negative 7? Just looking at this number line right here. Here's the number line for negative 5. Here's the number line for negative 7. Is negative 5 less than negative 7? No, that's not true. So you know that this side of the line is not going to have the thick line on it. It's not going to have a thick line on it. Because one of the sides of this circle are going to be true. One of them is going to be false. That's how you decide right now. We tested for truth, we tested for false, and we're good. Okay? One more example. No, you can have a negative integer. Look. If this was the other way around, those are both negative. Negative 5 is greater than negative 7. Look where the variable is. The variable's on the right on number 2. But I'm going to show you what to do after example 4. That will hopefully clear that up for you. I don't want to introduce it yet because I don't want people to be confused. Yeah? Say that again? Yeah, that's where it gets confusing. When the variable isn't where you want it to be. So I'll get to that right now. All right, example number 4. M over negative 3 is less than or equal to 4. M divided by negative 3 is less than or equal to 4. And as you guys know, with our equality work, M is being divided by 3, so now we have to multiply by 3. Or sorry, multiply by negative 3. Multiply by negative 3. Which just leaves M over here less than or equal to negative 12. Let's test that out. Let's test that out. Some of you might get angry at me with what we're about to do. Here we go. Okay. Going to make negative 12 be in the middle. Negative 11. Negative 10. Negative 13. Negative 14. So I should put a colored in circle here because it's less than or equal to, and M is less than negative 12. So I'm going to put this way. Let's test it out. Let's test it out. I wanted a funky color for what we're about to do. Let's go bright green's kind of hard to see. So test that M is less than or equal to negative 12 with one of those numbers. M is less than or negative 12 with one of those numbers. So let's use less than or equal to. Let's use, what are we going to use? Let's use negative 18 because that would be down the way. Okay? Wait, sorry. M has to be less than or equal to negative 12. So let's substitute anything in there that's less than or equal to negative 12. Yes. Negative 12. Let's make it more obvious so it's not right on the dot. Okay? Let's make it a little bit further. Yeah. Negative 21. Negative 21, we got to substitute in for M. So I'm taking the original that's written over here in black. Written over there in black. So you said negative 21. Negative 21, negative 3, less than or equal to 4. Okay? Negative 21, we have negative 7. Or sorry, no. 7 is less than or equal to negative 4. That's not true. We messed up somewhere. Actually, no, we didn't. I messed up on you on purpose so you'd be able to see what happens if you don't do this rule. Okay? False. I want you to write false. False. Oh, he's so mean. Why would you do that? That is not true. And I'll tell you why. That is false, false, false. And here's the way that you make it true. When you can scroll down. There we go. When you multiply or divide by a negative, flip the inequality. When you multiply or divide by a negative, flip the inequality. That will allow it to stay true. That will allow it to stay true. So here's how the exit. Whoa, what? So let's do that example when we flip it correctly. Oh, ouch. M over negative 3, 4. I have to multiply both sides by negative 3. Multiply by negative 3. I'm taking this negative. I'm multiplying by a negative 3. So my sign needs to flip. It was less than or equal to, but now it's greater than or equal to. Now it's greater than or equal to. And that one will come true when you label it. How do you graph that, he says? It is greater than or equal to. I'm going to color in my circle. If it doesn't erase, aha. Now with any substitution that I substitute into this M and put it in the original, which is black, that'll hold true. So any number that is greater than or equal to negative 12. So if I put that in there, let's say I do negative 12 itself, it's negative 12 divided by negative 3, and that is less than or equal to 4. What's that? Because the words greater than, greater on a number line is to the right. The word greater than. The word greater than. When I say the words here, when the variable is on the right side, right here, that is negative 5 is greater than or equal to x. Yes, I'm going to give you something at the very end, like I told you earlier, that will help you out. I promise. Okay? I'm literally like 20 seconds away from saying that in the lesson. So if you're confused right now, I completely understand, but I'm going to show you something as soon as I answer these two questions. Yes? Because we didn't multiply or divide by a negative. We divided by a positive number. Yep. Good question. Student asked why we didn't flip on number 3. It's because we divided by a positive number. If that was a negative, we would have flipped it. Yep. Okay. Star. Trick for graphing. Because this is for Stephen. Well, actually, it's for everybody, but Stephen's going to appreciate this. Trick for graphing. Put variable on left. Trick for graphing, you put the variable on the left. If it's on the right, number 2, -5 is greater than, actually, what was the original question? I've got it right here. So for -5, come on. -5 is greater than x. Flip everything. Then it's x. Now, be flipping, it's just flipping sides. Flipping sides. So it's going to be a mirror image of that. All I'm doing is just putting x in the beginning because I like the way that goes. Do you see that by having the different perspective of putting x first, these two say the exact same thing. -5 is greater than or equal to x is saying the exact same thing as x is less than or equal to 5. Yes?
Would it ever affect your answer, like on multiplication,
No, all this, not like that. Not this one, not for the trick for graphing. This is how this is saying, okay? On the left here, it's like saying, I am 5 years younger than my brother. And it's also the same thing saying, my brother is 5 years older than me. Do you have a sibling? Okay, how's your dog? Okay, what's the dog's name? You have an older brother, right? Okay, who came out first? By how much? Okay, so what's your brother's name? Okay, Ryan came out 1 minute before Daniel. Daniel came out 1 minute after Ryan. Same exact thing, just a different perspective. Right? Okay. Now, if you have, Stephen, the variable on the left, this is what the end of your graph is going to look like. Huh? All right, yep, here we go. This is the trick of it now. Okay? If it's on the left, don't lose me now. Don't lose me now. Yeah, we still got 4 minutes. -5, -4, -6. I'm graphing this one up to the right. Please stop tapping. If rats. Now, I just drew the line to the left. I'm going to stop talking. Stop talking. You might have it, but there are at least 6 people in this room that are anxious about not understanding this right now. So be quiet and listen. If you have a question, I'm happy to answer it, but if not, keep your mouth quiet. Look at this. As I said, when the variable's on the left side, that symbol is going to indicate the end of your line. That's the easy way to remember. That less than symbol is going to be the edge of your line. When the variable is on the left side, yes. And if the variable is not on the left side, you flip like this. Here's another way to look at it if you guys are getting confused about what I have written here with flip everything. See how the small part of the angle is pointed at the x? It's still the small part of the angle is still at the x. Okay? The arrow is shooting the x to the right over here. The arrow is still shooting the x to the left over here. Homework. No. It's my job to make sure, yes. What's that? It will be, yes, always is. Homework.
If I buy you a shirt for Christmas, will you wear it?
Thanks, but you don't need to buy me anything. Just come ready to learn. Okay, homework. Page 149. 17 through 24 all. And page 154. 16 through 32 even. And 33, yes there is. Yes, now you've learned how to graph, so I expect you to do it. Keep in mind that hearing it and writing notes, that's not the time that you. That's not. Yeah, all that is just putting the bread in the oven. Okay. When you do homework, that's when it starts to cook.
Yeah, but then the cooking is boring.
And then you eat it when the test happens. Mm-hmm.